Hello, this is the latest week of this module, and during this presentation the main concepts explained in previous lecture will be summarized. There are some preservation techniques which can lower the water activity, and let's mention some of them which lead in a reduction of the activity of water, such as curing by addition of the salt, conserving by addition of the sugar, or addition of other solutes like glycerol, sorbitol, lactate, propylene glycol, etc. The removal of water in fact can be achieved by drying or the immobilization of water by freezing. Most raw foods have a pH between 5.6 and 6.6. pH decrease enhance microbial stability, which can be achieved through naturally processes such as fermentation or artificially by the addition of acidulants. Strong acids that are used in food manufacture are hydrochloric and phosphoric acids, which are, for example, with a pH 3.3 or below. The redox potential of a food is influenced by the removal of the air, exclusion of light, addition of reducing substances such as ascorbic acid, sucrose, etc., growth of bacteria, presence of nitrite, temperature, pH. Let's now explain an important Hardel factor such as salt and the addition of sodium chloride to foods has been known for centuries, originally used in preserving or curing meat for long-term preservation prior to the development of refrigeration and cooling technologies. Sodium chloride does not itself possess the preservation and quality-enhancing effects of curing salts. The main effect of sodium chloride is the reduction of water activity. Sodium chloride in itself seems to have the bacteriostatic effect. Another Hardel factor is the nitrite, which is the functionally active compound most commonly used in modern meat curing and preservation processes. Its beneficial effect is the limit of the growth of serious pathogens such as Clostridium botulinum. Also, the salt can render the muscle tissue a bright pink color by the formation of nitrosamyoglobin. Another widely used physicochemical hurdle is carbon dioxide. Carbon dioxide slows down many quality degrading processes in foods and reduce or inhibit the growth of most spoilage bacteria. The solubility of carbon dioxide increases dramatically with lower temperatures, down to the freezing point of the foodstuff. As for application of oxygen as Hardel factor, can be said that in practice a lower than 21% of oxygen concentration can be considered as Hardel, while the absence of oxygen should improve quality and safety. At low oxygen concentrations, the growth of most but not all microorganisms is reduced or inhibited. The respiration rate of respiring produce is decreased, and many quality degrading processes are slowed down. Until now, we have talked about some major hurdles for food preservation with a natural physicochemical hurdles, including water activity, pH, redox potential, different salt used in the foodstuff, or gases such as oxygen, carbon dioxide, ozone, etc. Also, application of preservative is a powerful Hardel factor, including organic acid and their salts. Various acids are added to the foods for a variety of intended purposes, namely as acidulants, acidity regulators, preservatives, or antioxidants. The most widely used food preservatives are the weak lipophilic organic acids, including propionic, sorbic, and benzoic acid, or acidulants such as acetic acid. The N-dissociated molecule is responsible for most of the antimicrobial activity of the acids, which results in an increase in the rate at which protons enter the cytoplasm. Monolaurine as a miscellaneous hurdle is a food-grade glycerol monoester of lauric acid. Also, monolaurine has properties as food emulsifier. Besides its effects, has rather broad antimicrobial spectrum against gram-positive bacteria, yeast, and molds. Also, monolaurine has the greatest overall antimicrobial activity among all fatty acids and their esters. Other miscellaneous hurdles are free fatty acids. Some fatty acids have an inhibitory effect on bacteria depending on the degree of saturation and in the chain length. Free fatty acids, or FFA, are quite active against gram-positive bacteria, including pathogens such as Listeria monocytogenes, as linoleic acids and arachidonic acids. Now let's consider cytosine, which is a high molecular weight polysaccharides, and it is shown to inhibit the growth of a number of fungi, either directly manner or indirectly. In fact, due to its polymeric nature, cytosine can form films which are permeable to gases and in fact has the potential of being used as an edible coating. Chlorine is another miscellaneous hurdle, and it is not uncommon to treat food products with a chlorine wash, for example raw salad vegetables prior to modified atmosphere packaging and retail distribution. The most widely used is probably the produce is dipped for a short time in a hypochlorite solution which contains 50 to 100 ppm free chlorine. Related to compartmentalization hurdle can be said that the preservation of water in oil emulsions depend to a large extent on the product structures as for the butters, margarines, and low-fat spreads. When talk about microbially derived hurdles, the first to take into consideration is competitive flora, and the most striking example is fermentation. This is the process where spontaneous growth of distinct types of microorganisms may completely overgrow food, and by their mere magnitude supported by extrinsic and intrinsic factors related to the food in question, can arrest or inhibit the growth of other microorganisms. The fermentation can also be initiated by the addition of microbial starter cultures. Let's now explain the multifunctionality of sulfite as a food additive. It can act as bleaching agent. Also, it can act as antimicrobial agent because it has the power to inhibit growth of yeast and molds in a low pH and low water activity products. Also inhibits gram-negative bacteria in foods with higher pH and high water activity. Another characteristic of sulfite is that it is enzyme inhibitor because it can inhibit chemical and enzymatic reaction, for example, enzymatic browning. Also, sulfite can be Maillard reaction inhibitor because can prevent non-enzymatic browning. On the other part, can prevent oxidative rancidity and other oxidative reactions. Sulfite can act as antioxidant as it can prevent oxidation, minimize color changes, and stabilize the vitamin C. On the other part, sulfite can act as reducing agent and modifies flow rheology. Smoking as a hurdle can be said that this process was once an important component in the preservation of many cured meats and fish products, but today it is mainly used to give flavor and color. However, smoking is still an effective means of inhibiting undesirable molds growth for uses such as and hams. Phosphates are another chemical hurdles and are used as additive in several food products and have different effects. They can improve water binding capacity, rise the pH, or have an antimicrobial activity. Also has antioxidative effect and can act as chelators of trace metals which are used as catalysts in the microbial metabolism. Polyphosphates are always used in the combination with other aldehys, especially with curing, and from this the conclusion is that cannot be applied as the only aldehyde. Talking shortly for gluconodilactone or GDL, which when added to food slowly hydrolyzes to gluconic acid, subsequently lowering the pH. And is this that can contribute to safety and stability, for example in the case of cured meat products. As for the application of GDL as the only aldehyde, can be said that it is always used in combination with other aldehys and especially with the curing process. Phenols as aldehys, we can say that the use of phenolic antioxidant is well known in order to prevent or reduce oxidative deterioration of food products. Have some antimicrobial effect, especially in combination with other aldehys such as butylated hydroxytoluene, butylated hydroxyanisole, and 2-tertiary butyl hydroquinone. Phenolic antioxidants are used in combination with other aldehys, for example with packaging. Other chemical aldehys are chelators, and the most commonly used are citrates, lactates, pyrophosphates, and ethylenediamine tetraacetic acid. They are used in foods primarily for their antioxidative properties or due to their ability to eliminate the pro-oxidative effects of metals. As for the surface treatment agents are substances which inhibit the growth of the molds, and some cases are, for example, diphenyl, which is authorized for the use on the peel of the citrus fruit, or tophenylphenol is authorized for the use also on the peel of the citrus fruit. Thiabendazole is authorized for the use on the peel of banana and the citrus fruit. These preservatives may be the only extrinsic aldehyde for citrus fruits. Another chemical aldehyde is ethanol, and in the food can be presented as the product of fermentation, for example in the case of alcoholic beverages like wine, beer, etc., or other fermented foods. Can be as an ingredient in spirits or essence, in candies, confectionery products, sweets, etc., or as a residue after baking in yes fermented bakery products, or ethanol can be as additive when permitted in packed intermediate moisture foods by spraying before packaging or by desorption from packaging films, microcapsules or caps. The propylene glycol is one of the humectants which can be used to lower the water activity, for example in the case of intermediate moisture foods. Propylene glycol may have some antimicrobial effect and is used to inhibit molds in intermediate moisture foods. As for application as only aldehyde, can be said that is never used. Maillard reactions products. The Maillard reaction is a reaction between amino acids and reducing sugars. In fact, this reaction is very common during heating up foods, and the Maillard reaction products affect the color, the flavor, and the physicochemical properties of the food. As for the cases of spices and herbs as aldehys, can be said that there are numerous spices and herbs which have antioxidative and antimicrobial properties which can contribute to the stability and safety of the foodstuff. The most active components of spices and herbs that are found are phenolic compounds and essential oils. Uh, can be illustrated to the cases of garlic that is found at allicin, and in the case of mustard is found at allyl isothiocyanate. However, the concentration of spices and herbs in foodstuff necessary to result in significant antimicrobial activity is normally much higher than is organoleptically acceptable to most of consumers. I want to really thank you for your kind attention during this module, and it was a pleasure to giving you information about hardel technology, its application for food preservation. Thank you.